Hello everyone. Good morning, good afternoon, good evening. Okay, I am Bharath Kumar Musku, Design Verification Lead and Consultant. Today I am going to share a topic on Verilog and I would like to share this particular training with demo as well. Okay, now the audience for this particular training are Verilog learners and the topic I am going to share in this particular movie is about blocking and non-blocking assignments in Verilog. Okay, so to explain this particular topic, I had picked up one exercise problem. If you see in this particular snippet of code, right here, you can see the question as initial values of ABCD are respectively 10, 20, 30, 40. So we need to assign ABCD with 10, 20, 30, 40 after the execution of the following code. So execution in the sense, right, this is always procedural block, and when this particular block got executed once, like let's assume he haven't mentioned anything about how many clocks and so on. So let's assume on the first clock, right, this is very important interview question, and here it is clearly shown like on the first passage of the clock we want the values of ABCD, outputs of ABCD. So I will go to my whiteboard to illustrate what exactly he is asking here. If you see this, I had drawn a clock, right? Okay, this clock is toggling at every 10 nanoseconds. One clock is 10 nanoseconds, right? Okay, you can see one passage here. So you assume that clock is initially assigned to 0 and first passage happened here, right? Again, second passage will happens here. So in this a question to us, right? They haven't mentioned anything as such like how many clock and so on in this, right? So now we want to find at the first passage of the clock what will be the values of A, B, C, D, right? The question is clear, right? So yeah, if A, B, C, D assigned as 10, 20, 30, 40, it should be 10, 20, 30, 40 only, right? Correct? But you are seeing there are assignments. B is assigned with A, C assigned with B. So that means B got assigned onto C. But when they are getting assigned here, any guesses? Yeah, many of you might have understood that at first passage of the clock, we are assigning values of A to B, B to C, something like that. Okay, so on, D to C. So let's assume uh, here in this first clock, so A will be what? Irrespective of first clock or second clock, any clock, A never we are reassigning A. So always A will be 10, right? From here itself, like from the beginning itself, A will retain 10 until the end of the simulation, even how many clocks ever it is. Okay, yeah, let's move ahead and explain. I want to explain this in EDA playground. Okay, I had written a small snippet of code here. Initially, you can see ABCD are having values so assigned with ABCD as respectively, and I'm generating a clock. It is required because we are reassigning on every passage of the clock. So uh, for this module, so this non-block example module, so we are having a input called clock, right? So let me make it more relevant. This is our module, right? And it is having ABCD inputs and clock as well. Like okay, here I like in my thing I have in my code I haven't considered ABCD as a inputs, so they are internal variables. So clock is here. Okay, so right, like this is clock. Let's assume this is a clock here, right? So what is asking is ABCD are getting assigned, and what will be the ABCD values after 1 clock, right? So now going back here, that is what I have generated the clock here, and I am assigning here, and these are the output values, and dumping the signals so that we can visualize in the simulation the results, right? Okay. Yeah, how to use this EDA playground? If you want to understand that, please let me know in comment section, and please subscribe to my training to understand this particular language, Verilog. It's a hardware description language, by the way. And okay, let me go ahead and run this particular code, snippet of code. You can understand. Now, as I had enabled waveform after running, it will be opening a waveform here, right? So let me close this old ran waveform. So now once after the simulation completed, there are no compilation issues here. Right? Compilation passed. Now we can see the output. Here you can see B is initially 20, 14 in hexadecimal, it is 20. But at the passage of the clock, we are assigning with value A, right? So that assignment you can see. But if you see, C is initially 30, but at the passage it become 20. The reason is it's a non-blocking assignment, correct? You got the point here. It's a non-blocking assignments, and uh, blocking assignments are something which will be represented with equal to symbol. Let me go to my presentation again. So here equal to is called as blocking, and this less than symbol and equal to are considered to be as a non-blocking. So what is happening here? B is initially 20, but at passage, as this is non-blocking, immediately it will be passing the value, right? So that is where the thing is, right? So B become okay. Here, if you see in the waveform, B is 10 and C become 20. C become 20. There is no nothing blocking. So immediately the assignment takes place at the clock and it becomes 20. Right? Like versa, it will be going on. So as he haven't asked anything at the any particular clock, if you see after 1, 2, 3, third clock, all ABCD have the values of 10, 10, 10, 10, 10. You see here B get 10 and it's never changed, right? So that's where the answers lies the question. You need to understand the interviewer's question. Either is he asking at the post passage or any particular number of passages, right? So this way, this simulation definitely help you. And here I had displayed the outputs A, B, C, D. Here, if you see at zero simulation means we are not toggling the clock, right? If you see coming back here at the 5 nanoseconds only, we are triggering the clock. So at this triggering point, A become 10, B 10, C 20, and D 30, right? So values have been changed here. So if the interviewer asks you at first passage, this is the answer. If it is after third passage, there the answer is different. You see all have tens. So I hope this particular training help you to clarify certain things in Verilog, such as assignments, either blocking and non-blocking, and how the triggering is taking place. Also, how to display the signals in Verilog, and also how to dump and how to use EDA playground. All these 5 things you got understood from this particular video. Thank you, and please subscribe, at the same time like, and so that you can get my next uploads available straight away in the videos. So the main intention here is for you to understand exactly how, what is the theoretical learning, at the same time you want to learn in real simulations. Okay, and with that, in simulation we have seen, and concepts we had learned are always an initial procedural block. These are two separate topics actually. I would be explaining you in next further trainings. And please let me know if you need any particular topic in Verilog. We had seen simulation and the results. Finally, analyze what are the outputs, right? With that, thank you. I would like to stop this particular training. Bye.